side up, but I think we do pretty badly on the world scale. And the one thing that determined this summary health, gut health, if you like, which I'm calling diversity, where you want maximum diversity, the number one thing we found was not whether you were vegan, not whether you were vegetarian, not whether you were gluten-free or lactose-free or any one of these other religions, but actually just the number of different plants you ate every week. Okay? I'm talking not just, you don't have to have, and that doesn't mean having 20 portions of kale every day. It means having different seeds, different herbs, different spices, and it's mixtures of fruits and berries and nuts and all these kind of things together, because each of those are fuel for your microbes. And that was more important than whether you self said, I'm a vegetarian, I'm a vegan, I'm healthy, I'm a paleo person, I'm whatever. Okay? So that's the key. So you can do all those other things, call yourself what you want, as long as you've got lots of variety on your plate. You don't get caught in a rut. Now the government tells us to cut down on sugar, and they also tell us to cut down antibiotics, and we know that antibiotics are really bad for your guts. And today they're given out like Smarties, but we know that children given antibiotics do get fatter and do have more allergies. It's very hard to avoid it because a lot of antibiotics are in our food, in our meat particularly if it's cheap, or processed meat. Emulsifiers come in all kinds of sources, and we know that emulsifiers in processed foods do also influence your microbes, make them stick together a bit, stop them working. Preservatives, we know less about, we're worried about them, but we do know that artificial sweeteners, I don't know how many people here take an artificial sweetener on the basis it's supposed to be healthy. You're not admit to take any? One of you. Well, there must be more than that, but okay. Okay, so generally they're supposed to be inert, right? Not supposed to do anything. I went into a metabolic chamber and took some sucralose, which is the commonest one in the UK at the moment, and that's my, you can see my glucose went up. I was wearing a 24-hour glucose monitor, and so just having sucralose, it peaked. And this was telling me that these things are far from inert, and there are a number of studies now showing they reduce diversity and increase metabolic signals. So our whole idea of what foods are safe and non-safe needs a new thought when we start to think about our gut microbiome as a novel organ in our bodies. As part of my book, The Diet Myth, I did lots of studies, and I'd just come off a rigorous 3-day raw milk French cheese diet. Obviously, you tried it yourselves. Helped down only with the help of a little bit of red wine. And it was fantastic, just eating Efoisse, Roquefort, and Brie de Meaux, which are 3 unpasteurized cheeses you can easily get in the UK, because they have extra microbes. And I was trying to see if I could build up my microbes in just 3 days. I didn't, as a matter of fact, but I did enjoy very much the day 1 of the diet. Day 2, not so good. By day 3, I'd really had enough cheese for the week, I could tell you. And the next study I was going to do was to do the 10 days McDonald's challenge. Bit of a contrast there. Only all my meals at McDonald's, and I wasn't very looking forward to it because I wasn't not a big fan, but I'd do anything for science, of course. And it turned out that there was someone better qualified than me, someone actually liked eating burgers and fast food. He was a student, he was hard up for money, he was also my son. So he ticked all those boxes. Fantastic. So Tom did this, and all his friends used to follow him into the McDonald's and take pictures of him as he was getting all this free food, and the other staff knew him for those 10 days. He came back to me after just 4 days and said, I'm really not feeling very well. My friends say I'm getting a bit grey, and I think we ought to stop now. And as a concerned parent, obviously, I was worried about his health, but said, no way, we're going to carry on. We're going to publish this in the Sunday Times, which is exactly what we did. And when we published it after 10 days, he really was feeling even worse, and we even noticed, even in him, a drop in his academic achievements, which was something. But what was worse is he'd lost 40% of his gut microbes. So his diversity had plummeted in those 10 days. And really, we had to ask the reason why that was, because the traditional view of junk food, if you like, oh, it's just lots of fat and lots of sugar. It's a very sort of naive idea, and maybe chemicals. That's why you shouldn't have it. But from a gut microbe point of view, what happens when you have that kind of diet? You're not getting any fibre at all. They need fibre to live. Okay? The only fibre is a little green gherkin that the most kids throw away anyway. So he had 10 days with virtually no fibre and lots of fat and lots of sugar. And I think it's that imbalance that really messed up the gut microbes, messed up his gut health. And that's why we just need to think differently about this. That's where it was the lack of something rather than necessarily this idea that these things are all toxic. We need to be thinking, because microbes are good. The more you've got, the healthier you are, the better you are. If we destroy them other ways, then we're in real trouble. Now, he stayed bad actually for several years, as he kept reminding me when he wanted more money. But I think we may have finally sorted them out now. That's just an N of 1 study, obviously, and an anecdote. In our twins that we follow, half identical, half non-identical, we followed a group between 30 and 80, 3,000 of them, that we had very close measurements over, because this is the most detailed study of twins in the world that we run, and we have, every few years they come in for a test and a body composition scan, and we saw that over that time, as usual in middle age, most people gained weight. Very unusual not to, and those that had high fibre lost less weight, and particularly weight around the gut, the internal visceral fat, than those that had low fibre diets. And each extra gram of fibre people reduced their weight gain by 2 kilograms. So even a tiny amount of change in fibre seems to have a very big effect, and this was related to their microbial diversity, so we could directly link what they were doing with how it was changing the microbes. So we seem to now have a better understanding why fibre is good for you. It's not the old days of, oh, it's just roughage, it just passes straight through you and gets rid of toxins, which I was taught, a very physical presence of it as like a substance that just, cleared scouring the inside of it and cleared everything out. Now there's a real metabolic understanding that this stuff is there fueling your microbes. We also looked at the genetics of this, because in our twin study, virtually everything we look at turns out to be genetic, except whether you like Mr. Bean or what football team you support. This turned out to be a bit of an exception. It's not very genetic at all. It's about 10% or so heritable. Some microbes are genetic, but the vast majority seem to just go with the environment you live in and in your diet. And that was important for us, because it suddenly realised the potential to change your microbiome is much greater than to change your genes. Now, the other thing we looked at was pairs of identical twins. Remember, these are genetic clones, where one was much bigger than the other one. And you can't explain that in terms of their upbringing, because they live together till the age of 18 generally, and you can't explain it in terms of their genes, because they're identical in every cell in their body. So this particular pair differed by about 15 to 20 kilograms over most of their adult life, and when we added up these pairs, we found that in nearly all cases, the skinny one had more diverse microbes and had particular microbes that liked them and not their sister. And there are a couple of these that are called Christensenella and Akkermansia that we only found in the skinny twin. And when we looked, about 10% of people have this Christensenella microbe, and people that have it in high numbers always tend to be on the skinny side. And some people reported they could eat whatever they liked, snacking on things, they never got fat, aren't they lucky? And when we took these microbes from the twins and put them into mice, we could stop them getting fatter. Now, that shows you that it isn't just an association due to being skinny or being fat, but actually it's part of the causal pathway. And this is the clever thing about gut microbes is you can do the experiments in humans, but you won't know whether it's cause or effect, and then you can take those microbes, transplant them into these animals, and make them fat, make them thin, make them depressed, make them anxious, do all kinds of stuff to them, change their immune systems. And this is why we know that they're so important, and not just bystanders in what's going on. So this is really important. And there are companies now trying to experiment with these microbes, putting them into breakfast cereals and things, so everyone can eat as much as they like and stay thin. They haven't succeeded yet, though. That's how to do badly. How can you improve your microbes, I guess is the other question. And I don't know if any of you listen. An anthropologist called Jeff Leach, who's been studying the Hadza, who are a tribe that have been in this part of Tanzania for about 10,000 years, possibly 50,000 years, in exactly the same way. So one of the last hunter-gatherers on the planet, and they have 30 or 40% more microbes than we have, even the healthiest stuff. And they don't get chronic diseases, they don't get fat, they don't get diabetes, they don't get heart disease, they don't get cancer. They do fall out of trees and have other injuries and infections, etc., but they don't have any sort of allergies or disease we have. So we think it's their way of life, I think it's their microbes. And I've been there for 4 days to live with them, eat their meat, and basically ate what they did. No washing facilities, obviously, in the middle of nowhere. And as well as a fascinating time, I did manage to improve my microbes by about 20% or so in terms of diversity, but this was only a short-lived effect. As soon as I got back on the aeroplane home and started eating aeroplane food, I think everything dropped back to where it was. So I need to stay there a bit longer or keep going back there for a top-up. But it does show that by changing diets and environment, you can actually improve to some extent your microbiome. A bit about what foods are good and bad for your gut microbes. Everyone knows green vegetables are good, high in fibre, and there are certain fibres that are better than others. And the fibres, well, at least we've studied them. And so the ones we've studied is something called inulin, which is in, particularly in vegetables such as artichokes, both globe artichokes and Jerusalem artichokes, also known as fartichokes, that will have massive inulin, which the microbes break down and convert into very helpful things called short-chain fatty acids. So they're converting this, like as I said, they're chemical factories, converting the chemicals in the plants you eat into other useful substances. So knowing which ones these are, onions, garlic, leeks, all have very high amounts of these in it. And also, the legumes are useful. And then we have things that also have lesser amounts of fibre, but have other things that are important. So in the past, we've been told that drinking coffee is bad for you, peanuts are bad for you, red wine's bad for you, olive oil's bad for you. But it turns out that all these things, and dark chocolate, bad for you. It turns out the recent evidence is it's all good for you. So, okay? But the reason it's all good for you is not because we got it all wrong before, it's because they all have a chemical component in them that the microbes use, and that's called polyphenols. Okay, so polyphenols have been around. They used to be called antioxidants, which was just a general way of scientists and doctors pretending they knew what they were talking about. Because no one really understands why these things were helpful. It was just a general word for things that mop up nasty things. But this is a much better theory, because these polyphenols we can't actually use ourselves, but for the microbes it's rocket fuel. They love polyphenols, they break down, they get these polyphenols, they use them as energy sources, and they then convert that into other helpful chemicals for the lining of our gut and our immune system. So it's a sort of a good deal, basically, we get. And that's why the Mediterranean diet is particularly good for you, because of all these polyphenols, despite the saturated fat that traditionally we're told to avoid. And then we've got a few other things here, so you can see some yogurt there. How many people here have yogurt every day? Wow, look at you, like a commercial. How many people here have kefir? Okay, who hasn't heard of kefir? Okay, kefir is the new super yogurt, okay? You will have heard, now you've heard about it, but you'll start seeing it now. It's interesting, when it first came out a couple of years ago, no one had heard of kefir, and suddenly, where I live in Islington, it's in every shop, you can't move for bloody kefir. So basically, it's soured milk, fermented milk, and it has about 5 times more microbes than the equivalent amount of yogurt. So do get used to it. If you like yogurt, mix it up, and start having that as a top-up if you want your microbes. How many people here have kombucha? Well, I've got you there. Okay, kombucha is the next level. You see, once you've mastered kefir, you get a kombucha, which is fermented tea. So basically, you get and it comes from Russia, and it's very big in California, but it's taken ages to get here. But it's a fantastic drink, and it has about 2 or 3 times more microbes even than kefir. And you have fungi in there, but 3 times the fungi. Basically, you grow this mold thing that's called a mother. It's a bit like a sourdough mother, and you put it in your tea, and after 10 days, it converts the sugary tea into a really refreshing drink that has a slight sour acetic acid taste. It's packed with good stuff. Okay, so we're diverging slightly. We do the whole kombucha talk, but just to show you that these interesting foods all have this common thing. They're all really good to pick up microbes, either as fuel or as providing actual microbes themselves. Okay, these probiotics. Meat eaters. How many vegetarians in the audience? Not many. Okay, that's quite generational. Now it's about 1 in 6 of the population is vegetarian. Less are vegan, but a lot of people give up meat because they say it's bad for you, it's bad for the planet. They're partly correct, and most of the studies do show a slight harm of red meat over not eating meat. It's mainly processed meat that's particularly bad. But some people may be able to eat meat fine. It turns out your microbes can determine whether you're someone who processes meat in a healthy way, or you produce waste products drugs that give you heart disease. And so they've done a number of studies now that show that this just subtle difference in how our microbes break down some of the carnitine in meat to other chemicals makes a big difference. And like many other examples, there's what we call personalised nutrition. This was just to show you that there was a headline a few weeks ago that probiotics don't work. Remember that? No. Well, the idea that eating yogurt doesn't work because all the microbes get destroyed. Turns out that's partly true that most of the microbes get destroyed, but if you have a billion of them, there'll always be 100,000 or so that will get through and replicate. But they don't hang around in your gut. Basically, they're there to act as chemical signals for the others. They stimulate all the other microbes, and you get a big metabolic difference. When we start measuring not the microbes, but the chemicals they produce, we see big differences between yogurt eaters and non-yogurt eaters. And those same micro-metabolites that produce the chemicals, we've shown are actually good at reducing some of the internal fat using our twin study. So this is another way of looking at it. Thinking of them as chemical factories makes you understand a bit more why you're going for all this. Why so many of you are eating your yogurt because you obviously think it's good, despite the government telling you it's got fat in and you should avoid it. You should always have the full fat one, by the way, not the low fat one if you want to get most of the benefits. Now, just closing up there was a study a couple of years ago that we had a glycemic index of food. So this is on packets where they tell you this is what the carbohydrate content is, and you should, if you want to be able to avoid sugar spikes and things like this, you should pick low GI foods. But it turns out that an Israeli group studied this and found that actually what was more important than your GI index of your food was what your microbes were doing. Okay, so for some people what's good turns out to be bad. So for me, if I have grapes, my blood sugar goes up into the diabetic range of 9.4. If I have bread, I shoot up to about 11 or 12, which is not good. But I can have as much pasta as I like, I can have as much rice as I like, I can drink as much beer or wine as I like, so I'm happy. As long as I don't have too much bread. But I wouldn't know that if I hadn't done my own experiments. And what we're hoping is that we can start to measure people's gut microbes in order to predict which foods they should be preferentially having, so everyone should get some personal nutrition. We've started this huge study in the UK, in our twins, called the PREDICT study, and we've done 300 twins so far, doing this kind of 2 weeks of logging their foods, looking at their sugars, with these glucose monitors. That, I've got one on at the moment, you can now wear them for 2 weeks. This shows that one twin spiked when they drank Prosecco, and the other one didn't, and one spiked with rice, and the other one didn't. And these are just small life choices that you can make. If you thought about this regularly, you would know this can make a big difference what your favourite drink was. It's not like cutting out huge food groups, it's just making small choices that your microbes prefer. I found out that my average lunch at the hospital was tuna sandwiches on bread, thanks from Marks and Spencer's for 10 years, because that's what we had in the canteen, and I thought that was healthy, it's got a bit of sweet corn in it. Turns out that was every single time it was giving me a glucose spike, and probably responsible for me gaining 10 kilos over 10 years. If I'd known that now, I would have been in a much healthier position now. And so just these subtle things of changing what that carbohydrate is can make a huge difference to people's lives. So that's what my particular research is going for in the next 10 years. Now, if all this has failed and you can't work out how to improve, these tablets might be the thing for you. They're frozen poo tablets, and you just have to have about 15 of them and you get a total makeover. All right, and the Americans call them crapsules. They're always very good with the short, snappy phrases. But they're no longer a laughing matter because they are the #1 treatment for a very severe infection now called recurrent Clostridium difficile infection. People have too many antibiotics, get recurrent infections, and they can die, and people do die, but this has a 90% success. If you have a poo transplant from someone who's super healthy, and you're in this, and you're very sick, 90% recovery, which is 3 times better than the nearest current medical treatment. It also works for ulcerative colitis to the same extent as the latest drugs, and it's being tried in a number of other conditions. And so we know very little about it. It's a very crude tool, as you can imagine, in more ways than one, and everybody's different, so clearly we may have to match donors and recipients in ways we hadn't thought about. But they're using it for all kinds of interesting treatments, including treating diabetes, obesity, etc. So watch this space. Finally, just to recap, I think if you can think of your gut microbes with this gardening analogy, you can't go far wrong. It's a key aspect of nutrition. You've got to realise that food is a series of chemicals. It's not carbohydrates, fat, protein, and calories. Okay, start thinking of these as chemicals that react with other microbes there to produce all these chemical reactions which you need. And everyone needs more fibre. There's certain more polyphenols, more fermented foods. And we need to explore also the reactions with medicines. Everybody reacts differently with medicines as they do with the foods as well. And so none of this is being tested by modern science yet. We haven't caught up. And really, there's huge potential for personalised diets. And the one message I want to leave you with is diversity, diversity, diversity. The more you can do that, the better. And realise with 100 trillion microbes inside you, you'll never truly dine alone again. Thank you.
We're all human, and yet we all look different. Now, a lot about the way we look is down to our DNA, as we can see so brilliantly with these identical twins. From eye colour to hair colour to dimples to height, each pair of twins looks very similar. But look a little more closely, and you'll see that each person here is unique. In this lecture, we'll explore how much of the differences between us are down to genes, and how much is due to everything else. We'll be looking at what makes you unique. Welcome to the third third of this year's Royal Institution Christmas Lectures, and this lecture is all about us as a species. It's all about human diversity. But first, let's start off with a different species, which is very diverse indeed. Down here. So we've got an amazing range of different dogs here, and the astonishing thing about this is that they are all dogs. They all belong to the same species, and yet they look so incredibly different from each other. We've got a Great Dane, we've got a little Shih Tzu, and a tiny little miniature Dachshund. Now, isn't it amazing that there's all that variation in one species? Humans first started domesticating dogs about 30,000 years ago when our ancestors were hunter-gatherers, and then over thousands of years, we've somehow moulded all of these changes. So we bred dogs that are really good at going down burrows and chasing animals like the Dachshund, and this is all down to us interacting with this other species. Now, to explore this diversity and how it comes about in more detail, I need to introduce one more species, and my friend, geneticist, Professor Aoife McLysaght. This little species, or it's a beautiful Chihuahua in my arm. But this Chihuahua, of course, was bred as a companion dog. It's very, very cute. And dogs are especially interesting in terms of genetics because this huge diversity that we can see in front of us is actually down to quite a small amount of genetic diversity. They're, after all, just one species. And that makes it much easier to be able to figure out how the genes contribute to the changes that we can actually see on the outside. And so, for example, this little Chihuahua and other miniature dogs like this, the size variation is largely down to just changes in just one gene. Now, we're actually able to understand the genetic basis of some of this. Yeah, so many of the origins of these traits has been traced genetically. So we can get a real handle on how variation in our genes contributes to the kind of variance that we can see. So let's have a think about how all of this variation comes about. But for now, let's say thank you very much to our brilliant dog lineup. So all these differences have been bred into different breeds of dogs by breeders choosing dogs with particular traits and then breeding them on to the next generation. That's something called selective breeding. It's what Charles Darwin called artificial selection. And he imagined how we could continue thinking about this to see, well, does this happen in nature as well? So how do we get natural selection? And to really explain this, we're going to play a game with this demo, and we need 2 volunteers. Okay, let's see. Yes, you there in the little blue jumper? Come on down. I'll pick one there as well. Great. Freddie, lovely to meet you, Freddie. What's your name? Rebecca. Rebecca. So what you see beside you here are 2 habitats, and you can see very quickly that this is a mainly orange habitat. The floor is orange, and it's filled with these balloons, which are mostly what we're calling orange pebbles. And over there we've got a grey habitat with grey floor and grey pebbles. But in amongst the pebbles, there is something else. So here we have a mouse, and there's orange and grey mice in each of these habitats. And so we're going to put these in there, and Freddie, what